Good morning. This is Sumanna, working as Assistant Professor at Department of Biochemistry, Government City College, Nayapur. Today's our topic is factors affecting the catalysis. What are the factors which will affect the catalysis? We'll discuss in detail. See, before going into discussion, what is the definition of enzymes? Will should know. Actually, enzymes are biocatalyst. Bio means life. Catalyst means which can increase the rate of the reaction. So, enzymes are biocatalysts, which are the catalyst of life. And a catalyst can be defined as a substance that increases the velocity or rate of a chemical reaction without itself undergoing any change in the overall process. See, a catalyst will increase the rate or velocity or speed of the reaction in which reaction it is participating, and the chemical nature or structure of the catalyst won't be changed whenever it undergoes the reaction. And with this, the enzymes may be defined as biocatalyst synthesized by the living cells. Only the living cells can synthesize the enzymes, and they are protein in nature. It means enzymes are made up of amino acids. One exception is there, which is ribosome. This ribosome enzyme consisting of RNA as the its structure, and colloidal in nature, and also thermolabile. Thermolabile means thermo means heat or temperature. Labile means it will change. So enzymes will change according to the temperature and specific in their action. Only particular enzymes will do the particular reactions which are specific in nature. All the enzymes cannot do all the reactions. Those are specific in their action. And now these are the 8 factors which can affect the catalysis. Those are concentration of enzyme, concentration of substrate, effect of temperature, effect of pH, effect of product concentration, effect of activators, effect of time, effect of light and radiation. How these factors will affect the catalysis will discuss in detail. See, here if you see the concentration of enzyme, how it will change or affect the velocity of the enzyme reaction is that as the concentration of the enzyme is increased, the velocity of the reaction is proportionately increases. Here if you see in the graph, this is the enzyme concentration and this is the enzyme velocity. Here you are increasing the concentration of the enzyme in this way. With the increase in the enzyme concentration, the velocity of the reaction also is increasing. This is linear in nature. When you draw the graph, the concentration of enzyme against the enzyme velocity, you will get a linear graph. With the linear graph, what you can understand that with the increase in the concentration of enzyme, the enzyme activate velocity or speed of the enzyme reaction will get increase according to the concentration. And in fact, this property of enzyme is made use in determining the serum enzymes for the diagnosis of the diseases. This effect concentration of enzyme can be used in the diagnosis of diseases. How it will be used is that by using a known volume of serum. See, serum is nothing but the sample collection from the patient. By using the known volume of the serum and keeping all other factors. What are all other factors? Like substrate, pH, temperature, all other factors should keep at optimum level so that the enzyme could be assayed in the laboratory. By using all the factors at a optimum level and by knowing the known volume of serum, the enzyme can be assayed in the laboratory with the help of the factor, that is concentration of the enzyme. And the other factor is the concentration of the substrate. See, if you see the concentration of the enzyme, as the concentration of the enzyme is increasing, the velocity of the enzyme reaction also is increasing. But when it comes to the substrate concentration, increase in the substrate concentration also gradually increases the velocity of the enzyme reaction, but it will be within the limited range of the substrate levels, within the limited range of substrate levels. And if you draw a graph between by taking substrate concentration against the velocity of the enzyme reaction, you will get a rectangular hyperbola. Here you can see this is called, if this is like this, it is called rectangular hyperbola. The graph you will get rectangular hyperbola. Here you can see three distinct phases, that is A, B and C. These three distinct phases are showing differences. See, this A is linear. From here to here it is linear. And when it comes to the B phase, it is curve. It is curve. And when comes to the C phase, it is unchanged. There is no change at all. By this, what you can understand that, see, up to the half Vmax is nothing, Km. Up to the Km. What is the Km? Km is nothing but substrate concentration at half Vmax. Substrate concentration at half Vmax. Here you can see half Vmax, and if you plot the graph against the substrate concentration, you are getting the Km. Km is nothing but substrate concentration at half Vmax. Up to that particular point, that is, if you increasing the substrate concentration up to the Km, you will get the linear curve. It means as the concentration of the substrate is increasing, the velocity of the enzyme reaction is also increasing. And after above the Km, that is after the, if you increase the substrate concentration after Km, you will get a curve. It means it is independent of the substrate concentration. And even if you are increasing substrate concentration, there is a third phase, that is called C phase. Here nothing is changing, which is unchanged. Even if you are increasing the substrate concentration, the velocity of the reaction is not increasing at all. So in this way, if you plot a graph like by taking substrate concentration against the velocity of the enzyme reaction, you will get three phases. And here if you see, A is linear, B is curve and C is unchanged. And this A is also called first order reaction. What is the meaning of first order reaction? When the rate of the reaction is depends on a single reactant is called first order reaction. It means here the rate of the reaction, that is velocity of the reaction, is dependent on the substrate concentration. And when you see B and C phases, it is called zero order reaction. It means it is independent of the substrate concentration. The rate of the reaction is independent of the substrate concentration. So in this way, even if you are increasing the substrate concentration more than the Km, there is no change at all. Up to within a limited range only, the substrate increase concentration can increase the enzyme concentration, velocity of the reaction. And how it will function is that, suppose there are 100 molecules of enzymes, and each, suppose if you are considering that one enzyme molecule is getting reacting with the one substrate molecule, and if you are increasing the substrate concentration like from 0 to 200 or 300, each one, by adding each substrate molecule, each molecule of enzyme is getting bond with the substrate up to the 100 enzyme molecules. Then even if you are increasing the substrate concentration, there are no free active sites of enzymes to react with the substrate molecules. So even if you are increasing the substrate, there are no free enzyme is there to bind with the substrate. That's why only within a limited range, the increase in the substrate concentration can increase the velocity of the reaction. And the other factor is temperature. how the effect of temperature will be. See here, if you see, the velocity of a enzyme reaction increases with increase in temperature up to a maximum, and then it will decline. The velocity of the enzyme reaction increases with the increase in temperature up to a maximum, and then it will decline, and you will get a bell shaped curve is usually observed. What is the bell shape? Here you can see this is the bell shaped curve, and if you see here, this is the temperature which is increasing from 0 to 80 degree, and the enzyme velocity, that is rate of the reaction, is also increasing up to a maximum point, that is up to the 40 degree temperature. And after that reaching the optimum temperature, then it is decreasing, and after getting the optimum temperature, even if you are increasing the temperature, the velocity of the reaction will get decrease. Why it will decrease? Because see, if you see here, and how this temperature can be utilized in clinical significance, like that foods can be preserved in refrigerators at low temperatures due to reduced bacterial enzyme activity. See, if you are taking any food, if you are considering any food, it will be spoiled if you keep it for 3 or 4 days. How the food will get spoiled? Because of bacteria. And if you are keeping the food in the refrigerator, which is maintained at 4 degrees centigrade, the bacterial enzymes are in the form of inactive. The bacterial enzymes will be inactivated state. So these bacterial enzymes cannot do any metabolisms in the food, any reactions in the food, so that the food cannot be spoiled by keeping in the refrigerators. And one more significance is that certain surgeries are carried out by lowering the patient's body temperature, called induced hypothermia, so that it can decrease the metabolic rate, so that the surgeries can be done. In this way, this is the clinical significance of the temperature on the rate of the reaction. And one more concept is there, that is temperature coefficient. What is the meaning of temperature coefficient is that, which is also called Q10. Q10 is defined as a increase in enzyme velocity when the temperature is increased by 10 degrees centigrade. Suppose the temperature is 20 degrees maintained. Suppose you are increasing the 10 degrees temperature, it means from 20 to 30. What is the change in the rate of the reaction? That you should consider. That is called temperature coefficient. And for majority of the reaction, this Q10, that is temperature coefficient, is 2 between 0 degree centigrade and 40 degree centigrade. What is the meaning of 2 is here, the rate of the reaction will get doubled. 2 means it is getting doubled only up to from 0 degree centigrade to 40 degree centigrade. It means, suppose the reaction is started at 0 degree centigrade, you are increasing the temperature from 0 to 10, then the rate of the reaction will get doubled. And from 10 to 20 degree centigrade increase, again the rate of the reaction will get double. In this way, the Q10 for most of the enzymes is 2 between 0 degree centigrade to 40 degree centigrade. And increase in temperature results in higher activation energy of the molecules, and more molecule are, that is enzyme and substrate collisions and interaction for the reaction to proceed faster. See what happens if you are increasing the temperature, the activation energy is also increased, so that more enzymes and substrate will get collide. Only with the collision the reaction will get occur. So with the increase in the temperature, the rate of the reaction, the activation energy will increase, so that more collisions will occur, then the rate of the reaction or speed of the reaction is also increases. And the optimum temperature is nothing but the the temperature at which the activity of the enzyme is highest, that is maximum activity is there. That temperature is called optimum temperature. If you see in the graph, see from 10 to 80, when you are considering this 40 degrees centigrade, the enzyme activity is more, the enzyme velocity is more. So this 40 degrees centigrade is the optimum temperature. So the optimum temperature for most of the enzymes is between 35 degrees centigrade to 40 degrees centigrade. Actually, what is our body temperature? 37 degrees centigrade. So most of the enzymes have the optimum temperature, that is at which the temperature at which the rate of the reaction is more is between 35 degrees centigrade and 40. And however, a few enzymes, examples are Taq DNA polymerase, muscle adenylate kinase, are active even at 100 degrees centigrade. This Taq DNA polymerase and muscle adenylate kinase enzymes are active at the 100 degrees centigrade. And some plant enzymes like urease have the optimum activity around 60 degrees centigrade. And this may be due to a very stable structure and conformation of these enzymes. What is the stable structure? Even if the increase in the temperature, the 3D structure, that is tertiary form of the enzyme, is maintained by even at the highest temperature for these enzymes. In general, when the enzymes are exposed to a temperature above 50 degrees centigrade, what happens? Denaturation leading to dearrangement in the native tertiary structure of the protein and active site are seen, and majority of the enzymes become inactive at higher temperature about 70 degrees centigrade. See, what is the enzyme, how the enzyme will be in the active form is that the proteins are first in the primary structure, then secondary structure, then the tertiary form of the structure. And all the enzymes to be active, those should be in 3D structure, that is tertiary form, then only the active site will be formed. So if you are increasing the temperature, the non-covalent bonds, van der Waals forces, hydrogen bonds, all these non-covalent bonds will be broken in the tertiary structure, so that the denaturation of the enzyme will be occurs. Then there is no active site at all for the substrate binding. So with the increasing in the temperature, denaturation leads to the dearrangement in the tertiary structure of the enzymes, so that there are no active sites for the substrate to bind. So for all the enzymes, optimum temperature should be maintained to be active. Next is effect of pH, and how this pH will affect the enzyme velocity is that this increase in the hydrogen ion concentration, that is pH, considerably influences the enzyme activity. What is the hydrogen ion concentration? Is nothing but pH. And here also a bell-shaped curve is normally obtained. See, for all the enzymes, one optimum pH will be there. At that particular pH only the enzyme will be active. And each enzyme has the optimum pH at which the velocity is maximum. Below and above this pH, that is optimum pH, below and above, the enzyme activity is much lower, and at extreme pH, the enzyme becomes totally inactive. See, this is the optimum pH, and below this pH and above this pH, the enzyme activity is low considering the optimum pH. And for few examples are there, that is most of the enzymes of higher organisms shows the optimum activity around the neutral pH. See, what is our body pH? That is 7.4. So most of the enzymes have the optimum pH at neutral, that is 6 to 8. But some exemptions are there, like pepsin, which is present in the stomach. So stomach is acidic in nature because of HCl, that is hydrochloric acid, And for this enzyme, that is pepsin, the optimum pH is 1 to 2, and for phosphatase enzyme it is 4 to 5, and for the alkaline phosphatase the optimum pH is 10 to 11. And enzymes from the fungi and plants are most active in the acidic pH, that is 4 to 6. These are the exemptions considering most of the enzymes. And these hydrogen ions influence the enzyme activity by altering the ionic charges on the amino acids, particularly at the active site, substrate, enzyme substrate complexes. By altering the ionic charges, this pH will affect the enzyme activity. Next is effect of product concentration. See, what is the function of the enzyme? Enzyme will react with the or binds with the substrate, then forms the enzyme substrate complex, then it will gives the product. So here how the product will affect the catalysis we'll see. The accumulation of the reaction products generally decrease the enzyme velocity, and for certain enzymes the products combine with the active site of the enzyme and forms a loose complex, thus inhibit the enzyme activity. And in the living system, this type of inhibition is generally prevented by a quick removal of the products. See, if you see, this is the enzyme will react with the substrate, will give enzyme substrate complex, then which will give the enzyme plus product. Suppose if the product is formed, this product will go and binds with the enzyme, okay, binds with the enzyme, so that it is filled with the product. So there is no space or active site for the substrate to bind with the other substrate, so that it will decrease the enzyme velocity. And what happens in the living systems, whenever the product is formed, it will be removed quickly. So the product concentration will decrease the enzyme velocity. Now, effect of the activators. What are the activators? How it will affect the enzyme activity is that some of the enzymes require certain inorganic metallic cations like magnesium, manganese, zinc, calcium, cobalt, copper, sodium, potassium, etc. for their optimum activity. And rarely anions are also needed for the enzyme activity. Example is chloride ion for amylase. Mostly the cations like positive charged ions only will be required. Some exemption are there, that is for amylase chloride ion is required. And metals function as activators of enzyme velocity through various mechanisms. Those mechanisms are combining with these metal ions may combine with the substrate in the formation of enzyme substrate metal complexes, and direct participation in the reaction and bringing a conformational change in the enzyme. In this way, these metal ions affect the enzyme activity. And two categories of enzymes requiring metals for their activity are distinguished. Those are metal activated enzymes and metalloenzymes. What is the difference between these two categories are, when the metal ion is tightly held by the enzyme, is not tightly held by the enzyme and can be exchanged easily with the other ions, are called metal activated enzymes. Here the metal is loosely bound with the enzyme and it can easily exchange with the other ions. Examples are ATPase, which require the cations, that is Mg2 plus and Ca plus to magnesium and calcium. And the other example is enolase, which requires the magnesium ion. And the other category of enzymes are called metalloenzymes. And in this type, the enzymes hold the metal ions tightly, which are not readily exchanged. Here the metal is tightly with the enzyme. Examples are alcohol dehydrogenase, carbonic anhydrase, alkaline phosphatase, carboxypeptidase, and aldolase. All these enzymes contains zinc, which is tightly held with these enzymes. And other examples are phenol oxidase consisting of copper, pyruvate oxidase which has manganese, xanthine oxidase has molybdenum, cytochrome oxidase which has iron and copper, which are tightly bind with these enzymes. And effect of time, how the time will affect. See, under ideal and optimum conditions like pH, temperature, it means suppose the concentration of the substrate is maintained, enzyme is maintained, and the optimum conditions like temperature, pH, all the conditions are maintained, then the time required for an enzyme reaction is less, and variations in the time of the reaction are generally related to the alterations in pH and temperature. Suppose the temperature is low, then the reaction will occur slowly. Suppose the optimum temperature is maintained, then the time required for the enzyme reaction will be less compared to the above and below the optimum temperature and pH. In this way, the time will affect the rate of the reaction. Next is effect of light and radiation. How these will affect that? Exposure of the enzymes to ultraviolet, beta, gamma and X-rays inactivate the certain enzymes due to the formation of peroxides. So when these enzymes are exposed to these rays, that is UV, beta, gamma and X-rays, it will deactivate the enzymes by forming the peroxide ions, so that the enzyme will be inactivated and there is no reaction at all. Example is UV rays inhibit the salivary amylase activity. UV rays which will inhibit the salivary amylase activity. In this way, all these factors will affect the enzyme reaction or velocity of the reaction. What are those factors? Concentration of the enzyme. What happens in the concentration of the enzyme? As the concentration of the enzyme increases, the rate of the, that is velocity of the reaction also will get increased proportionally. Next is effect of substrate. What happens in the substrate? Within a limited range, the substrate concentration can increase the rate of the reaction, and there you get the three phases. In the first is linear phase, second is curve phase, and the third phase is unchanged. Even if you are increasing the substrate, it won't change. Then is effect of temperature. For all the enzymes should have optimum temperature. And pH, all the enzymes also should have optimum pH to undergo the reaction. Substrate concentration, three phases will be there, that is A, B and C, that is linear, curve and unchanged. Next is temperature and pH. Optimum temperature and pH should be maintained. And next is product concentration. With the increase in the product, the rate of the reaction will get decreased. Next is time. Under ideal conditions, that is optimum pH and temperature, if you are maintaining, the time required for that reaction will be less. Next is effect of light and radiation, that is UV, beta and gamma X-rays will deactivate the enzyme so that there is no reaction at all. All these factors will affect. And thank you to all.